Welcome to AI Podcast. I'm Ethan, joined by my co-host Maya, and today we're digging into a fresh EMNLP paper called The Hidden Strength of Disagreement.
I love that title already. Hidden Strength of Disagreement sounds like a meeting that actually went well. What's the big idea here?
The headline is simple. When you have a team of language model agents working in a changing environment, it helps if they talk to each other, but don't force a single group decision every time. That little bit of disagreement makes the whole system more adaptable.
So not chaos, but also not lockstep marching. Who wrote it?
Zengqing Wu and Takayuki Ito from Kyoto University.
Nice. All right, give me the problem in human terms. What's wrong with just voting and moving on?
Think of a team of responders showing up to a citywide emergency. If they vote and send everyone to the same fire, the other fires smolder and spread. A lot of multi-agent LLM systems do the equivalent. Debate, vote, pick one plan. That works for stable tasks, but in volatile settings, it collapses exploration and you miss signals.
Got it. So what do they propose instead?
They push something they call implicit consensus. Agents still exchange information in a short dialogue, acknowledge what others see, but then each agent makes its own call. After the chat, one drone goes north, another checks the hospital, another monitors the power grid. Same conversation, different actions.
That feels like a good stand-up meeting. We agree on the situation, then split up the work. Why would that be better?
Because it preserves what the authors call moderate diversity. Not everyone chasing the same thing, not everyone going in random directions either. They actually formalize diversity as how far each agent's action is from the group's center of gravity, and they find performance follows a Goldilocks curve. Too little disagreement and you get groupthink. Too much and everyone trips over each other. The sweet spot is in the middle.
I like the Goldilocks framing. How did they test this?
3 dynamic scenarios. First, a disaster response grid where LLM-controlled drones pick which cells to cover as fires and injuries pop up and move. Second, a network where misinformation spreads and defender agents need to contain it while an adversary keeps injecting falsehoods. Third, a public goods game where each agent decides how much to contribute to a shared pot that keeps changing.
So emergencies, rumor control, and the classic, do we all chip in for the streetlight problem?
Exactly. Across all 3, they compare implicit consensus to explicit consensus, and they run a bunch of baselines. No diversity, no interaction, pure random choices, and even a single model working alone. They vary how turbulent the world is, and they try different language models, so it's not tied to one provider.
Before we jump to results, what does diversity look like in practice? Are they just telling models to disagree?
Not blindly. They induce structured diversity with role prompts. Think medical drone, logistics drone, infrastructure drone. Those roles nudge preferences without banning any action. Everyone can still choose any grid cell, but their priorities differ a bit. That creates informed disagreement rather than noise.
Okay, so the experiment is set. What happened?
In the disaster setting, the implicit teams cover more of the map, waste fewer actions, and respond faster when new trouble pops up. Under higher volatility, coverage pushes into the mid-90s, while explicit consensus lags far behind. In the misinformation setting, implicit consensus spreads the defenders smartly across the network, so false stories die out sooner and the final footprint is smaller. And in the public goods setting, the teams meet the changing threshold more often, total welfare goes up, and free riding is less of a problem.
That's a nice trifecta. Did they show why it works, beyond the metrics?
They looked at the agent chats. The implicit teams say things like, "This report might be wrong, but I'll go check," or "You take the West and I'll sweep the center," and when new info arrives, they pivot. The dialogue looks like people dividing cognitive labor, acknowledging uncertainty, and course-correcting together.
So the conversation is the glue, but the actions don't have to be identical. You mentioned that Goldilocks curve earlier. Did they actually see it?
They did. When disagreement is almost zero, performance suffers because the group locks onto one priority and misses emerging issues. When disagreement is very high, performance also dips because efforts fragment. In the middle, performance peaks. It's basically a visual inverted U.
Let me poke at a possible objection. Couldn't you get the same effect by adding random noise so agents don't all pick the same thing?
Great question, and they tested that. Random diversity doesn't help. It just scatters effort. What matters is purposeful heterogeneity, roles that push agents to notice different signals and, after talking, to make complementary choices.
Do the wins depend on having the fanciest model?
The advantage of implicit consensus holds across different backbones. Stronger models do better overall, sure, but the relative benefit of keeping moderate disagreement persists whether you use a top-tier model or a lighter one. They even tried mixed teams and saw the same story.
All right, time for the skeptic corner. What should we keep in mind before we generalize this to the real world?
A few things. First, these are simulated environments with small groups compared to real city-scale systems. Second, the approach relies on short, repeated dialogues, so very long histories or heavy tool use could stress memory and cost. Third, the metrics are sensible but task-specific, and because results depend on commercial APIs, replication across providers and settings takes care.
Plus, if you let agents act independently, you still need guardrails so they don't do unsafe things while they're being wonderfully diverse.
Absolutely. Implicit consensus is not governance. It's a coordination style. You'd still add oversight, auditing, and escalation paths.
If I'm building a multi-agent system tomorrow, what's the pragmatic takeaway?
Encourage conversation, then let agents act. Seed roles that create complementary perspectives. Track how similar their actions are, and tune prompts to avoid both uniformity and chaos. The goal is a gentle bias toward diversity, not disagreement for its own sake.
And maybe rotate roles or adapt them as the world changes, so you can stay on that Goldilocks ridge instead of slipping to one side.
Exactly. The authors also point to future work like scaling to larger teams with smarter communication patterns, measuring diversity at the plan or intent level, and mixing humans into the loop.
Quick analogy to end on. This feels like a newsroom on deadline. Everyone meets for 5 minutes, shares what they're seeing, and then reporters fan out. If everyone writes the same story, the paper is thin. If everyone writes something unrelated, it's a mess. But a little overlap and a lot of smart coverage makes a great issue.
That's the paper in a nutshell. Talk together, act separately, and keep disagreement in the productive middle.
Right. So the hidden strength of disagreement is that it keeps teams nimble without tearing them apart.
Well said. This was The Hidden Strength of Disagreement by Zengqing Wu and Takayuki Ito from Kyoto University. I'm Ethan.
I'm Maya. Thanks for listening to AI Podcast. See you next time.